Hello guys, today we are going to talk about humidity, geographic distribution, time variation, and measurement. First, we will define what is humidity. Humidity is the concentration of water vapor present in the air. Water vapor, the gaseous state of water, is generally invisible to the human eye. Humidity indicates the likelihood for precipitation, dew, or fog to be present. Humidity depends on the temperature and pressure of the system of interest. The same amount of water vapor results in higher relative humidity in cool air than warm air. A related parameter is the dew point. The amount of water vapor needed to achieve saturation increases as the temperature increases. As the temperature of a parcel of air decreases, it will eventually reach the saturation point without adding or losing water mass. The amount of water vapor contained within a parcel of air can vary significantly. Let's talk about humidity in the Philippines. Humidity refers to the moisture content of the atmosphere. Due to high temperature and the surrounding bodies of water, the Philippines has a high relative humidity. The average monthly relative humidity varies between 71% in March and 85% in September. The combination of warm temperature and high relative and absolute humidities give rise to high sensible temperature throughout the archipelago. It is especially uncomfortable during March to May when temperature and humidity attain their maximum. Humidity plays an important role for surface life. For animal life dependent on perspiration or sweating to regulate internal body temperature, high humidity impairs heat exchange efficiency by reducing the rate of moisture evaporation from skin surfaces. This effect can be calculated using a heat index table, also known as humidex. The notion of air holding water vapor or being saturated by it's often mentioned in connection with the concept of relative humidity. This, however, is misleading. The amount of water vapor that enters a given space at a given temperature is almost independent of the amount of air that is present. Indeed, a vacuum has approximately the same equilibrium capacity to hold water vapor as the same volume filled with air. Both are given by the equilibrium vapor pressure of water at the given temperature. There is a very small difference described under enhancement factor below, which can be neglected in many calculations unless high accuracy is required. Geographic distribution and time variation. The quantity of atmospheric water vapor varies with location and time. These variations may be attributed mainly to temperature and source of supply considerations. The greatest concentrations can be found near the ocean surface in the tropics, the concentrations generally decreasing with latitude, altitude, and distance inland from coastal areas. About half the atmospheric moisture can be found within the first mile above the Earth's surface. This is because the vertical transport of vapor is mainly through convection action, which is slight at higher altitudes. It is also of interest that there is not necessarily any relation between the amount of atmospheric water vapor over a region and the resulting precipitation. The amount of water vapor contained over dry areas of the southwest, for example, at times exceed over considerably more humid northern regions, even though the latter areas experience precipitation while the former do not. In the video shows the chart for the climate map of the Philippines indicating the different types of areas with different seasons for the whole year round. There are three primary measurements of humidity employed, which are the absolute, relative, and specific humidity. Absolute humidity describes the water content present in the air and is expressed in either grams per cubic meter or grams per kilogram. The absolute humidity in the atmosphere ranges from near zero to roughly 30 grams per cubic meter. Mathematically, absolute humidity is defined as mass of the water vapor divided by the volume of the air and water mixture. The relative humidity of an air-water mixture is defined as the ratio of the partial pressure of water vapor in the mixture to the equilibrium vapor pressure of water over a flat surface of pure water at a given temperature. It is normally expressed as a percentage. Higher percentage indicates that the air-water mixture is more humid. Relative humidity is a crucial metric that is used in weather forecasts as it an indicator of the likelihood of precipitation, dew, or fog. In hot summer weather, a rise in relative humidity increases the temperature to humans by hindering the evaporation of perspiration from the skin, while specific humidity is the ratio of the mass of the water vapor to the total mass of the air parcel. A device used to measure humidity of air is called a psychrometer or hygrometer. A humidistat is a humidity-triggered switch, often used to control a dehumidifier. The humidity of an air and water vapor mixture is determined through the use of psychrometric charts if both the dry bulb temperature and the wet bulb temperature of the mixture are known. These quantities are readily estimated by using a sling psychrometer. There are several empirical formulas that can be used to estimate the equilibrium vapor pressure of water vapor as a function of temperature. The Andoy equation is among the least complex of these, having only three parameters A, B, and C. Other formulas such as the Goff-Grach equation and the Magnus-Tetens approximation are more complicated but yield better accuracy. The Arden-Bach equation is commonly encountered in the literature regarding this topic.